Hi, this is Wemi. The paper I'm presenting today is Collaborative Unsupervised Visual Representation Learning from Decentralized Data. Unsupervised visual representation learning has emerged as a powerful method to learn visual representations without expensive labels. These methods are applied to learn representations on centralized data available on the internet. However, growing amount of decentralized image data collected in multiple parties may not be centralized due to data privacy regulations like GDPR. For example, images collected from street cameras could contain sensitive personal information. Besides, learning representations directly from the extra data may be more representative for downstream tasks applied on similar scenarios. Hence, it is important to navigate a solution to learn representations from decentralized unlabeled data. An intuitive solution to conduct training on each edge, but as edges could have limited data, the data could be non-independently and identically distributed, non-IID for short. Such training will result in bad performances. Federated learning is an emerging privacy-preserving distributed training method. Different from centralized training, federated learning share model updates from clients to server instead of raw data. The majority of federated learning methods rely on data labels, but the images are mostly unlabeled when collected. Labeling this data is expensive. Besides, two existing works implement federated unsupervised learning for unlabeled data, but they either bypass the non-ID data problem or could impose potential privacy risks from sharing features to construct a global dictionary. To address these issues, we propose a new federated unsupervised representation learning framework, namely FedU. It comprises a server and multiple clients. The framework contains 4 key activities: local training, model upload, model aggregation, and model update. Firstly, clients conduct local training using contrastive learning. After training, clients upload the trained models to the server. Thirdly, the server aggregates these models to get a new global model. Lastly, the server updates client's local models with the global model. We iterate these 4 steps until it meets the stopping conditions. Specifically in local training, we adopt the self-supervised learning method, BYOL. After local training, we obtain 1 predictor and 2 encoders in each client. There are 2 important questions for communication between client and server. First, which encoder should we upload for aggregation? Second, which encoder should we update with the aggregated global model? For model upload, we upload only the online encoder because it is trained with the gradient descent, representing more newly learned knowledge. For model update, we update only the online encoder with the aggregated global model because the target encoder needs to provide regression targets for local training. Last but not least, we consider whether should we update local predictors with the global aggregated predictor. To answer this question, we designed a module called Divergence Aware Predictor Update, DAPU for short. Divergence means that non-ID data causes model divergence in federated learning. As we can see from the figure, that federated learning diverges from centralized training. So we propose DAPU to update local predictors with global predictor only when the divergence of local training is smaller than a threshold mu. The intuition is to use global predictor when divergence is small and use the local predictor when divergence is large. Next, let's look at the experimental evaluation. This table compares performances of our method, FedU, with other methods. Our method outperforms all other methods on CIFAR datasets under IID or non-IID settings. We also provide in-depth ablation studies. For communication protocol, the table shows that aggregating and updating the online encoder achieves the best performance. For divergence-aware mode predictor update, compared with using only global or local predictors, the DAPU achieves much better performances. In conclusion, we introduce a new framework, FedU, to learn generic representations from multiple parties by leveraging decentralized unlabeled data. We hope that FedU will encourage the community to explore learning visual representations from decentralized data under privacy constraints. Thank you.